Hello everyone, my name is Nikita and I'm from the Bodhi Academy. In the last video, we had started with the chapter Carbon and Compounds and we had reached up to the nomenclature of different hydrocarbons when there are single, double and triple bonds between the carbon atoms. Okay, so today we are going to see different other forms of carbon compounds when a functional group is attached to it. So today we are going to see the different functional groups and the nomenclature and the properties of the functional group, how it becomes different when the functional group is attached to it. Okay. So what is a functional group? Now by the name itself we can say that this group will do something to the functioning of the hydrocarbon when attached to it. So it is called as a functional group. Okay, so now there are different functional groups, and when these functional groups are attached to the parent chain, to the hydrocarbon chain which we had studied last time, it changes the properties and the characteristic of the chain of the entire hydrocarbon regardless of the length of the chain. However long is the chain, but the attachment of a particular functional group will change the properties of the carbon chain. Okay, so now, and this functional group is called as a heteroatom. Okay, so the first functional group is a halo group. Halo means a halogen. So in terms of halogen, it can be chlorine, bromine, iodine, fluorine. Okay. Now the next functional group is an alcohol group. An alcohol group which is represented by OH, addition of the OH group to the hydrocarbon. Third one is an aldehyde group. That is C double bond O H. Okay. Now the fourth one is a ketone group wherein you add a double bond O to the carbon. Okay. And the fifth one is a carboxylic acid group. Acid group wherein the formula is C double bond O OH. Okay, so first we have the halogen group, then we have the alcohol group OH group, then we have the aldehyde group C double bond OH. Okay, then we have the ketone group which is C double bond O, and the last one we have is carboxylic group which is C double bond OH. Okay, so now these are the different groups. Each of the group when it is attached to the hydrocarbon chain, it changes the properties of the hydrocarbon chain. Okay, now let's see one example. Now this is a C2 carbons are there over here, and okay, now in place of hydrogen I am adding an alcohol group. In place of hydrogen, now I'll be adding a alcohol group, and we see that the valencies are already satisfied. So how do we write the formula of this? The formula will be C2 H1 2 3 4 5. 5 H are there, and there is an alcohol group which we write separately as OH. Okay, this can also be written as I have previously told, this can be written as CH3, considering this part CH3, and considering this part then CH2, and then this OH. This can be also written this way. Okay, so now sometimes it happens that a series of carbon compounds are substituted, the hydrogen is substituted by the same alcohol group, okay, and this series is called as a homologous series. For example, if I take one carbon, okay, and it will be CH3OH. The second one, two carbons, C2H5OH. Then three carbon, C3H6OH. Okay, so this is a series of carbon, where a series of hydrocarbon wherein the same functional group is substituting the hydrogen. Such a series is called as a homologous series. Homologous series. Okay, so now these are the functional group and this is about the homologous series. Now I've said that the functional group is changing the properties of the hydrocarbon. This also means that it will change the naming of the hydrocarbon, the nomenclature of hydrocarbon. So depending upon the functional group, each hydrocarbon has a prefix or suffix. Each of the functional group have a prefix or suffix which has to be added to the main name, the base name. Okay, now let's see what is the prefix. So first one, the halogen. First halogen has the prefix as if the functional group is chlorine, okay, then in case of chlorine it has a prefix and it is chloro. Okay, in case of bromine, okay, it is bromo. In case of iodine, it is iodo. And in case of fluorine, it is fluoro. Okay, so this is for halogens. The naming has a prefix. So how it is done? If suppose this is the compound, the hydrocarbon, okay, and one hydrogen is substituted by chlorine. Okay, and now first we have to see the number of carbons. So number of carbons over here are C3 and H is H7. Okay, H7 chlorine. Now we know that when it is C3 and there is no double bond here, it is a single bonded compound, means it is saturated compound. In that case, the naming of this, the base name of this hydrocarbon chain is propane. Okay, propane. So now you have to add the prefix, okay, prefix to this propane, and the prefix, as it is chlorine over here, the prefix is chloro. So the name of the compound will be chloro. It will be chloropropane. Chloropropane. Okay, if the carbon is 4, okay, and hydrogen are 9 and there is one bromine attached, then the name of this one will be C4. So it is butane, right? It is butane, and as bromine is attached to it, it will be bromobutane. Okay, see, for bromine you have to add bromo, the prefix. Okay, so this is how you name the carbons when the hydrocarbon chain, when the halogens are attached to it. First you have to see the number of carbon atoms and recall the base name, and then you add the prefix to it, okay, depending upon which halogen is present. Now the second one is alcohol. Alcohol, the formula for it is OH. Okay, here we have seen that the formula of alcohol is OH. Okay, so now over here you are adding a suffix. Suffix means after the parent chain. Okay, now the suffix is AL. Okay, the suffix is AL. For example, now this is a C4 hydrocarbon chain. Okay, now in place of hydrogen I'm adding an OH over here. So the name of this will be, okay, so count the number of carbons, it is 4. So 4 means it is butane. Okay, actual name is butane. So when you add a suffix, okay, you have to write the name first and then minus E. Okay, remove the E. Okay, and this will be now this will be butan. Okay, and then you have to add this OL over here. Okay, OL, and the name of the compound will be butanol. Name of the alcohol will be butanol. So whenever you are writing an alcohol, it is OH, and whenever you write naming the compound, then you have to minus the E from the base chain and add OL, it is butanol. Okay, so in case of alcohol, the suffix to be added is butanol, OL, after minusing, after subtracting the E from butane. Okay, now the next one is an aldehyde. Okay, for the aldehyde the formula is C double bond OH, and the suffix to be added is AL. Okay, so now, okay, so for aldehyde it is C double bond OH. Now for this we need to understand that the actual functional group is this. Okay, this is attaching to the original carbon. Okay, to the carbon already present in the chain. This part is attaching to the carbon already present in the chain. So for example, if I write 3 carbons here and satisfy the valency of the first 2 carbons, okay, then for this carbon this thing will get attached. Okay, so it will be C double bond OH. Okay, this is getting attached, and let's see if the valency is satisfied. C 1 2 3 4. Yes, it is satisfied, so no need to put another hydrogen over here. Now once you see that this is the functional group, you have to do it same way. Okay, write the parent name, the base name first. Looking at the base name, there is no double bond between the carbon. There is double bond here between carbon and oxygen, but no double bond between the carbon. Okay, so and it is 3, so the name is propane. The base name is propane, and then you have to minus the E. This will be propan, and then add Al. This will give you propanol. Okay, so the name of the compound is propanol. Okay, so the next one is a ketone. For ketone, you add the suffix SONE. Okay, now the formula for ketone is C double bond O. There is no H, there is no OH. It is just C double bond O. So when you write C double bond O, it should be such a carbon which is present in between. It can't be the carbon which is present at the end, because you do not want HOH which for the valency to be satisfied. It should have two carbons on either sides. So first one, that is methane and ethane, these two of the carbons, because they have 1 and 2 carbons, the ketone functional group cannot be attached to it. So we start from propane. 3. So now here I will first add the double bond O, that is the ketone group, and I will satisfy the valency of all this. Okay, now as there are C double bond here, now there are 3 carbons, so the base name is propane minus E. Okay, this will be propan, and then you add O and E to it. The name will be propanone. Okay, it will be propanone. So for addition of ketone, you have to see that the carbon is in the middle and the suffix is ONA, propanone. Okay, now the last functional group is carboxylic acid. Acid, this has C double bond O, OH. Okay, and the suffix is OIC. Okay, it has C double bond OH, means again you have to know that this OH, okay, this part is getting attached to the last carbon. Okay, whatever the parent carbon is, you have to remove H from there and you have to attach this C double bond O, OH to it. Okay, so now let's see. Okay, we'll satisfy the valencies of all the other carbons first. For this carbon, I will add the hydrogen or the functional group directly. Okay, so now you can see that I have added the functional group, and let's see the valency 1, 2, 3, 4. It is satisfied, so no need to add hydrogen over here. Now the naming is, you have to add a suffix oic the same way. Okay, the same way. Now first you will see what is the base name. 1, 2, 3, 4, 5. There are 5 carbons and there is no double bond between the carbons. Okay, so 5 means it is pentane. Okay, then you have to minus E from that will get you pentan. Okay, now because it is C double bond OH, it is OIC, and the name of the compound is pentanoic, and this is called as an acid. Okay, these are carboxylic acids, and all the compounds with this group are named as acids: butanoic acid, ethanoic acid, methanoic acid, and pentanoic acids. Okay, yes, so this is how the nomenclature changes with the addition of functional groups. Okay, now one more thing is that the compounds which are present, the hydrocarbons can also be present as in the cyclic form or as closed chain. The two examples of this are, okay, cyclic forms. The one example is cyclohexane. Cyclohexane. For this you have to represent the hexane structure in the form of a cyclic form. Okay, this is a hexane structure, but it is closed. Okay, it is closed. Now over here it is closed. So this is basically this one. This is basically this one which is joined over here. So over here whatever hydrogens were there will get cancelled out. Okay, now to satisfy the valency I have to add the hydrogen. Now we know that this carbon already is bonded with two other carbons, so it is 1, 2 and 2 hydrogens will be added. So 1, 2. Same with this, 1, 2. Then this one, 1, 2. Then again this one, 1, 2. 1, 2. 1, 2. Okay, and the name of the compound will be C6H12. Okay, so this is one hydrocarbon. Now the next hydrocarbon is cyclic hydrocarbon, is unsaturated one, which the ring will have alternate double bonds. It is hexane only, but the ring will carry an alternate double bond. So there will be a double bond here, then single bond, again double bond here, then single bond and again double bond here. Now let's see how the valency will be satisfied. Okay, so for this one the valency is C1, 2, okay, C1, 2, 3, and I just need one hydrogen for this carbon. Then again for C1, 2, 3 and 4. C1, 2, 3 and 4. 1, 2, 3 and 4. Same here and again same over here. So the name of this compound will be, the formula is C6H6 and the name of this compound is benzene. Okay, it is benzene. So yes, today we saw what were the different functional groups and some cyclic structures and how the naming of the compound changes as you add the functional group to it. Okay, so yes, thank you for watching my video. Please like, share and subscribe to our channel.